Hello friends, welcome to this lesson on clamp meters explained. In this lesson we will cover the three different types of clamp meters, their operating principle and how to use them. What is a clamp meter? It is an electrical testing instrument that measures current without direct contact, by clamping it around a wire. Types: current transformer, CORT, clamp meters, measures AC current only. Hall effect clamp meters, measures both AC and DC current. Flexible clamp meters, measures AC current only. Now let us look at the operating principle of current transformer clamp meter. It uses the principle of a current transformer. When current flows through a conductor, a magnetic field is created. The conductor to be measured is assumed to be the primary winding. The clamp is assumed to be the secondary winding. Due to electromagnetic induction, a current proportional to the primary current is induced in the secondary winding, which is connected to the measuring circuit. This current on the secondary winding is proportional to the primary current. This current is then converted into a readable value on the display by the clamp's measuring circuit. The below is a diagram of a current transformer clamp meter. It has a display screen, clamps and a rotary switch. Now let us look at the operating principle of a Hall effect clamp meter. But first, what is a Hall effect clamp meter? It is a clamp meter that measures AC or DC current by using Hall effect sensor. A conductor carrying current creates a magnetic field. A Hall effect sensor detects and converts the magnetic field into voltage. What is Hall effect sensor? It is a semiconductor that generates a voltage proportional to magnetic field passing through it. This voltage is then amplified and converted into current. The current is then displayed on the clamp meter's display. Procedure for using a CT or Hall effect clamp meters. The procedure is the same for both clamp meters. It is as follows. Turn the rotary switch or dial to on position. Select the appropriate DC or AC current range, that is, if your conductor is expected to carry 10 amperes, choose a range higher than 10 amperes, for example 20 amperes. Open the clamp's jaws and clamp the conductor that you want to measure its current. Note: clamp one conductor at a time. Close the jaws of the clamp meter. Read the current on the display in amperes. Open the clamp's jaws and unclamp the conductor that you have measured its current. Close the clamp's jaws and turn the dial to off position once done measuring. Now let us look at the operating principle of flexible clamp meters. But first, what is a flexible clamp meter? Flexible clamp meters are also called Rogowski coils or air-cored coils or flexible current probes. They don't have an iron core unlike CT and Hall effect clamp meters. It uses a helix-shaped coil which responds to the rate of change, known as the first derivative of a conductor's magnetic field around which they are placed. An air-cored coil is placed around the current-carrying conductor. The magnetic field produced by the AC current induces a voltage in the coil. The Rogowski coil produces a voltage that is proportional to the rate of change of the current enclosed by the coil loop. The coil voltage is then integrated in order for the probe to provide an output voltage. Hat is proportional to the input current signal. Note: they are flexible for measuring current, thus can fit into tight, cramped spaces. They can measure AC current only, as they can only respond to the rate of change of a signal. The diagram below is for a Hall effect clamp meter. It is very similar to the one of CT clamp meter, as both have an iron core. The only difference is that Hall effect have a Hall effect sensor. The parts are clamps, display screen and the dial or rotary switch. The diagram below is for a flexible clamp meter. This is different from both Hall effect and CT clamp meters as they don't have an iron core. It uses helix-shaped coil. The parts are clamps, display screen and the dial or rotary switch. Let us look at the summary of differences in CT, flexible and Hall effect clamp meters. 1. CT clamp meter. Principle of operation. Uses electromagnetic induction. Measures AC current only. Core type: rigid ferrite or laminated iron core. Advantages: simple, rugged, and reliable. Accurate for sinusoidal AC currents. Limitations: cannot measure DC. Limited flexibility, that is, it must fully enclose the conductor. Bulky compared to flexible clamps. 2. Hall effect clamp meters. Principle of operation: uses the Hall effect sensor. Measures both AC and DC currents. Core type: solid magnetic core with Hall sensor embedded. Advantages: can measure DC current, a major advantage over CT type. Can measure low frequency AC and distorted waveforms. Limitations: more expensive than CT type. Accuracy affected by external magnetic fields and temperature. Bulkier than flexible types. 3. Flexible clamp meters or Rogowski coil type. Principle of operation: Uses a Rogowski coil or air-cored flexible coil. Measures AC current only, there's no DC, since there's no magnetic core. Core type: flexible, no iron core or air-cored coil. Advantages: very flexible, can wrap around large or awkwardly shaped conductors. Lightweight and easy to carry. Ideal for large AC currents that is even 1000 of amps. Limitations: cannot measure DC. Requires integrator circuitry to convert coil voltage to a current reading. Slightly less accurate at low currents compared to CT or Hall sensors. Thank you for watching our channel. Please like, comment, share and don't forget to subscribe. May God bless you.